Hello, thank you all for coming down. This is a much bigger attendance than I had last time I spoke because I was competing against Tridge. So I think I'm doing a lot better this time around. And of course, all of my equipment has gone bad on me, so we'll cope. It is on. I can hear myself on monitors. Well, is there anything I can do here to make it loud? Okay, we're going up to max. Fantastic. It's got no numbers on it, so we can't get to 11, sorry. And the lights. 50. Off. Okay, lights look good. Okay, that's just the abstract that we put on the website for LTA, so I'm not going to talk through it in too much detail. Mosh is a nice bit of software that's been designed to replace the primary usage of SSH, as in getting a shell on your server, to do it in cases where your network is unreliable, is laggy, is changing. To do this, it doesn't use TCP to connect, it uses UDP to talk to your server. It doesn't care about your source IP address, and it tries to take care of it with encryption. So some of that makes me a bit nervous. So, is it safe to mosh? It's a difficult one to answer. I start off, you can't quite see Roger's name on there. Roger is one of our operators back at the university who's spent many, many years doing music photography of punk music only. He loves his job. We're not talking about slam dancing too much. So what Mosh does is it tries to deal with the use case that you're on a reasonably unreliable network. So the first thing that they really wanted on there was the roaming issue, which is where your IP address keeps changing out from underneath you because you're popping off the network on again and you get new assignment. Or in some cases, you're switching to a completely different network off of Wi-Fi onto a 3G. Because a lot of the mobile networks tend to be very laggy, they've put in a bit of work to try and cope with the problem that SSH had, with the fact that the input and the output stream was pretty much all the same, and your keystrokes have to be echoed by the far end. Mosh doesn't do that. Mosh will echo your keystrokes from the client side, but only when it's confident that they're going to be right. So it keeps an eye on your session, and it's line-based in that case. If you hit return, it has no idea what's going to happen next. It makes some predictions, and when those predictions are confirmed by the server, it gets confident and starts making more right in front of you. So it looks really, really responsive. You can do all your line editing long before even the first character has got to the server. They describe it as a replacement for SSH, which is a little bit enthusiastic, I think. It's not a replacement for all of SSH, it's a replacement for that one use case of getting a shell. So we don't get the port forwarding, we don't get the wonderful VPN, we don't get X, any of that. They're working on some of those ideas. It's not necessarily going to work for all of it. So, is it safe to mosh? Well, these guys here look very confident and happy, right? So they're using Mosh and it works for them. That guy there is looking very happy because he knows something you don't know. Maybe. These guys look happy. They're getting a little bit distracted by their circumstances. Right? But on the whole, they look like they're enjoying themselves and everything's sort of under control. This guy has a problem. Something's gone badly wrong. Behind him. That's not his foot, as far as I can tell from the photo. And I don't think he's found it yet. So basically, it really depends. So is it safe to mosh when you slam dance? Yeah, of course it depends exactly what you're doing. Are you staying off at the sides and concentrating on the band? Or are you getting slammed around in the middle? And the same is true of Mosh as choosing to use it in a safe manner. It does depend very much upon who you are and what your environment is and how much control you have over it and how much you don't. So a home user who generally has all of their own kit, all of their own responsibility, that's one type of decision they're going to make. And these are the people that don't even bother reviewing their logs on a regular basis or even know that they've got them. And a small business, the admins, the techs, are usually the people that are going to make all of the technical decisions, and they're not going to bother the business with it because a small business is going off making money in its own corner, and all this tech stuff is just a necessary overhead. But when you move up to enterprise, we have people setting rules and policies. They don't address changes in technology in the outside world. We have CISPs all over the place who say it can't be safe because it doesn't have the right number of fire extinguishers on it. And we have network security, which means network inertia. And then we have me, who sits in an information security office and says no to as many things as possible, but we're not allowed to say no to any of these people because they're our clients, and we have to find ways of making it work in a happy way. I've got another what is Mosh. This one must have come off the website. I'm not going to waste time on this because I think you've just seen that a few times. So the high points of Mosh is the things that are really good about it, the things which make it very compelling. If you're roaming between networks, if you spend a portion of the time with no network and get it back again later, like you're walking across the green here at LCA, or let's say you've come out of a Wi-Fi and it'll take a while till you get to the next one, or if you sleep your laptop before you take it home, and you want to be able to just open it up and have your server sat there ready to be talked to without you doing anything extra at all, Mosh is fantastic. Because of their SSP protocol, which they put in to do all this with, which we'll get into a little bit more detail soon, the whole connection is really, really responsive. If you start off a big find of everything and you go, Control-C, Control-C, it'll work because the input and the output channels are separate. You hit the Control-C, it'll send that down to the server. Forget about what's coming, it'll do it straight away. Talked about the predictive local echo. As soon as it's confident that it knows what this line is doing, that the server is agreeing with its predictions, it will start throwing up your text right in front of you, letting you edit it, and let the whole server catch up with it later. They've implemented their terminal in UTF-8. They're actually holding a complete terminal at the server end. They've made it as clean UTF-8 as they possibly can. They've made it cleaner UTF-8 than they possibly could. You basically can't brick it with any of the things which brick everybody else's terminals. You can't turn your prompt into hieroglyphs. You can't get mixed between UTF and the ISO escape codes. It'll deal with all that. That's the best one. All the main distros have already picked it up. It's a nice, mature product. It's been the version 1 that we're on at the moment. I think we've been running for about 18 months. It's well supported, well supplied. Possibly a high point is it runs completely from user space. It has no way of being root, finding out who you are, and then going off and switching to your user. It doesn't do any of that. It says you're responsible for, as your user, going into your user space and running Mosh. Being able to receive UDP is the only thing that you're going to need the administrators for. This seems to fit with a lot of people's ideals. This is just some code that I can put in my home directory and run, and then I will get this benefit. The rest of you users, sorry guys. You know. Again, that depends on who you are and where you are. Now, in theory, I should be able to demo some of this. I don't know how well that's going to come off, but we'll give it a shot. Luckily, one of the things I need is an unreliable network. And unfortunately, I'm on the LCA network at the moment.
Everyone start streaming the live stream.
Yeah.
What's your MAC address? What's your password?
I don't know at the moment. Hang on. I'll get it around. Actually, I'll just go for it. So I found a little hosted virtual machine provider sitting up in Canada. Sorry, while my brain is doing passwords as words, it can't do talking at the same time. I'm single-threaded. So I found this cloud service provider up in Canada somewhere where it seems like it's been very enterprise. Somebody has bought far too many VMware boxes and had no use for it. So they've started selling them off. This machine is a mid-spec, little low-spec VM box that's cost me $35 for life. Not for my life. Sorry?
What was the name of this service provider?
Cloud at cost. You get what you pay for. You have to be careful with them. There's a little aside. Obviously, it's an enterprise back-end that has now been exposed to the internet. So if you choose to go to the website and fill in your username and password on the form at the front, you won't get HTTPS because you didn't ask for it. Enterprise. When you get there, they tell you all of your passwords in plain text on the page in front of you because it's enterprise. However, it's a long way away from me most of the time. So, logged into this box. Yeah, they gave me a Debian. That's great. Let's have a look. We'll see. Every now and again, you'll see underlines show up on my text. This is the predictive echo coming in. The first thing we want to do is say, whoa, hello. Forget the grep because I was talking instead of typing, and the same part of my brain isn't used twice. SSHD is running, but we're not using it. That's nice. We're on a shell hanging on the back of Mosh server, which is running off the back of init now. It doesn't belong to anything else. You didn't see what happened when I logged in because that's just the nature of the front end of the client. We logged in over SSH, quietly, while you weren't looking. As soon as we got a shell, we ran Mosh server. Mosh server sets itself up on UDP, and then we exited from the SSH, and then went back to the same IP address with the port number that the Mosh server just told us about, with the key that it had just told us about, and made a connection in. It's very nice. It will update your utemp. It will tell you where you've come from at any given moment and what you're doing. Never disconnect from your sessions, eh? Now, nothing's going to happen at this point. If I type in who right now, and hit the keys nice and loudly, you don't see anything happen because there's no packets going anywhere.
What happened with the predictive echo now?
It can't get any confirmation from the server that its initial predictions are correct because it knows after the 3-second timeout, because it's got a heartbeat at 3 seconds, it knows it's not connected to the server, so there's no way it can get validation.
That's why it doesn't even try showing underline.
Right. Let's try reconnecting to LCA. Ooh, I didn't do that. The packets have been sent as soon as we got connected. I'm not quite sure why it doesn't have an IP address on at this stage. I think it's simply because
That might have been the initial SSH login, so your IP's changed, has it?
the IP has not yet changed.
Oh, yeah.
I've just reconnected.
Oh, yeah, so you did set that up the same way.
Yeah. I don't know why the middle one is just sat there and not giving us an IP address. I suspect that the bit where the update utemp comes in a little bit later than when they start processing the initial packets. So, but still, that's quite cool. We can have the network drop out on us. I don't know the police password. Okay, so my client is telling me now my network has gone unreachable. It knows that straight away, of course. The edge your own connection seems to take a long time. So we'll just sing a little song while we're waiting for the wireless to make its way in. It seems to, I've tried it a few times, yay, we're in. Who am I now? My IP address has changed, but my shell's still here, my session is still here. Now, some people will be feeling a little bit cold. Some people were feeling warm and fuzzy. I dare say it's got something to do with your Apple logos, because your laptops go to sleep a lot and you like to open them back up again and be exactly where you were. But that's only because I don't have one. So we've got that there working quite nicely. And I'll just do some fast typing because I don't actually type as fast as they do in the movies. And you can see that predictive line popping up as we're going along. I don't think it knows what language I'm typing in, but yeah, that wasn't even a valid thing to do. But we quite like this. I can dump this session now, as long as the client on the laptop still exists and still knows the key for the connection. It'll be able to make that connection back to Canada whenever, when I get back to the hostel or something if I want to. I think that went stunningly well. Yes, sir.
Can you cat a binary file? Show us the...
Can I cat a binary file? Okay.
Be random.
Sure, yeah, okay. Yeah. Oh.
Doesn't count. It's trying to cheat.
Oh, yeah. Count equals 1. What's the other argument? Size. BS. What should we give it? 20? 30? Oh, I'll give it a... okay, we'll give it a reasonable chance of bricking me, shall we? There we go. So there's a chance that would have bricked the terminal. Do it a few more times. It's recovering nicely. Cool. Right, so what I'll do is I'll hit return to find slash and somebody shout out, you sir, shout out when you want me to hit Control C. That doesn't normally work, does it? It's great. Oops. Yes, sir.
Does the key ever expire between the client and server?
Does the key ever expire? I will cover that a little bit later on. Yes, it does. When the key expires, so does your session.
Those keystrokes you typed in that didn't echo, they were remembered, which might be a little bit disconcerting.
So the keystrokes I typed in which didn't echo were remembered, which is when I was disconnecting, yeah?
And when you reconnected, even though they didn't echo, you put those keystrokes into it, which
Oh,
is
oh.
a little bit disconcerting.
And when I reconnected, those keystrokes came back. Yes, it can be a bit disconcerting, I guess, if your network is losing and you're typing ahead without really looking. But that command is probably in the buffer somewhere in life. I don't know about that part in great detail. That's a good observation, though. Yeah. Yes, sir.
Can you make the home and hidden keys work?
Oh.
Whatever you type, will end up there eventually.
Right, so we have the comment that's a pretty similar case under SSH when your network is misbehaving. Okay, cool.
Home and end keys.
Beg pardon?
The home and end keys.
Home.
People love A and B, control A and B, but
Yep.
screen it really sucks.
Home and end key. So that's a home key and that's an end key. It did move the... I'll do that. I'll do that at the top of the screen because I think there may have been an AV problem here. So pressing the home key brings the cursor to the front. Pressing the end key takes the cursor to the end. Thank you very much.
Do you support pluggable login providers? Like, do you use Telnet instead of SSH?
Do we support pluggable login providers so we could do something instead of SSH? Yes and no. The simple answer is we don't support any login at all. So you can do what you like. It's even been suggested that somebody would start their Mosh server and get the required port and key information out from it, encrypt it with their private key, shove it into DNS, query it over here, and then connect to it. And that would probably work quite nicely. I think it would be insanely mad to do it, but it doesn't matter, right? It's completely irrelevant. This is running in user space. As long as you can get information from the startup of the Mosh server securely, knock yourself out. We'll cover the startup in more detail. But we're doing well. I'll go to the...
So without a login session like that, you couldn't do something like challenge response, so you couldn't do, say, two-factor auth.
We're talking about doing two-factor auth, query whether that will work with Mosh. Yeah, because it's coming in over SSH by default on its first connection, it will do whatever SSH is going to do. And that will get you from the public port 22 listener down to a user, at which point Mosh starts up, and then we get frightened about that later. I want to carry on though, so Okay. There we go. Obviously taking a long time to load images off the disk or something. My little slow laptop. Thanks to Dick Smith. So yeah, where's your two-factor auth gone? It could be going there. Okay, so just in case that demo wasn't going to work, I picked up, unfortunately, just screenshot it off my Android tablet, so the resolution's disgusting. This is Juice SSH on the Android, which supports Mosh. It's connecting, and at this point here, it's going through. That's the normal SSH dialog going through. And there we see just a couple of quick updates on what we've covered there. I show that we're not using SSH after we get our shell. Our shell has come from a Mosh server. I didn't show either way that the Mosh server is actually running as my user, not as anybody else. And just showing our IP address data going into who. When we disconnect, we get informed at the client end that the heartbeat has failed, so we know what's going on. Reconnect. Switch to a different network and get a different IP address. And I tried to catch the type ahead. It doesn't show up very well, but perhaps at the top of the screen it's a bit better. So what you get when you install Mosh, your lovely Debian package, you get a whole bunch of extras for documentation, but fundamentally you get two binaries, the Mosh server and the Mosh client, and you get a helper command called Mosh, which is a Perl script. I did have a quick look up and down the Perl script. It does a bit of input sanitation on your command line because it will allow you to pass SSH information through to the far end. But I didn't bother going too far down the process of trying to exploit it because it's logging in as me anyway, so I could already exploit the server. So I didn't worry about it. It looked pretty, it looked okay. So that's how you use it. You just run Mosh with options. Your host is, you can have an optional command at the far end if you don't want it to run a bash, a login shell. So it connects the server SSH, starts the Mosh server. The Mosh server emits its UDP port number that it's just successfully claimed, and it gives you the key that it's using. Nice big 128-bit key. Puts it on standard out, so it's completely your problem to collect it and bring it back safely. Then it drops the SSH connection, and it starts up the Mosh client by telling it the port number and the key. A couple of things just to look out for that are missing. We don't have scroll back on that terminal. Mosh is running its own terminal at the far end. If you want scroll back, go get tmux. If you've got screen, go get tmux. It's not fully mature yet on the things that I would worry about that it needs to log. We know that when we successfully change IP address from the client and come back again, that we've got information going into utemp, so we could log that change. It's not logging that. I would like it to. It's trivial to add it, I believe. There's a whole bunch of things around denial of service attacking, that it's going to be rejecting packets, but I would like it to log the fact that it's doing so. It should be logging out of sequence packets, but unfortunately they find a lot of networks are so laggy that out of sequence packet is a normal operation thing and not an attack, and they haven't figured out a nice way to differentiate between them. The thing that I find a little bit annoying is if your client has died and gone away, and your client has lost its knowledge of the key, you can't get that back again, and the server end is going to wait forever. So it's not perfect in every respect, but if you know about these things, you can work around it. Right. What's actually going on is we start off over here on your client side. You run Mosh client and you get yourself PTY. The Mosh client sets up two objects in memory. The session state synchronization protocol. Sorry, I don't have notes on display on my screen. But it sets up the input and the output channel idea. One of them is a representation of your terminal and the complete state of your screen, top to bottom. 80 by 25 or whatever size you happen to be. And the other one is keeping track of your keyboard, of your user input. So it's a bi-directional thing. And it sets up at the far end the same two objects inside SSP, which is why you can have one side flushing the output of fine, and the other side is, while that one's full and busy, this guy says, no, I've got a way back. I'll do an interrupt real quick. The transport layer of SSP takes care of looking at the state of those two objects and working out the changes between them, pushes it down to the datagram layer, which takes care of the key and the encryption, drops it over UDP, gives it a sequence number as well, just for good luck, and then at the far end it goes up the stack in the same sort of way. So the SSP transport layer looks after these two abstract objects. One is a terminal state and one is your keyboard. And SSP is designed to be use case neutral. It doesn't care what the objects are that it's looking after. Mosh, the terminal program, cares what it's looking after, but SSP, the protocol, does not know and does not care. Basically, it says if you can diff and patch, if you can describe the changes in state between where I am now and where you are now in terms of diff and patch, then I will work out how to quickly and most efficiently get to the current state. I don't know why they didn't use Git. Jerry Hess would say that they should have always used Git if this was their problem space. Never mind. The transport layer also keeps track of the round trip times and makes some decisions about when to send packets and when not to send packets. So you did a little bit of, you hit Control-C, it's not going to go instantly. It's going to wait until the next appropriate time based on whatever your current round trip looks like, except they will guarantee to go within 50 milliseconds, I believe. And they try and keep the traffic requirements low. So doing this over UDP, they have to do, of course, their own tracking of state and retry. And again, similar to that Control-C example, they're delaying when they're doing the acts to try and make the best use out of what your network is currently estimated to be capable of doing. SSP datagram is the bit where I was sort of worried because I really felt quite uncomfortable about what they're claiming to do. So the payload comes in from the transport layer, and the datagram layer has no particular knowledge of this thing at all. It takes it, it shoves it through OCB mode using that key, and then it starts sending things out over UDP and really doesn't care. It puts a sequence number on them just to make sure that you can detect when you got out of sequence stuff. On the way back in, it's the one doing the encryption, so it gets a packet coming back in with a very, very small plain text header, and then big lump of encrypted data, so it decrypts it and validates it, and if it is a valid looking datagram, sorry, the transport layer I think is the one that would actually have to validate it, sorry about that. The datagram layer has to decrypt it and then it passes it to the transport layer. The transport layer is the only one that understands the format of what it's doing, so it validates the packet and rejects them when it's people just knocking on the door. The datagram layer is doing lots of timestamping and trying to do the measurement of the network, which is information it passes back upstream. I don't know if authentication is strictly the right word to use for this bit. We've got this 128-bit key. We've got small sequence numbers on the front. That's a 63-bit sequence number that they just keep incrementing. So literally, when you look at it on TCP dump, the first packet is number 1, the second packet is number 2. Everybody tends to do their sequence numbers in plain. You asked about session dying. They're running this 128-bit AES all the way up to 2 petabytes. And then they're killing it, which I think is about correct on terms of the maths. They're using the full spread of the available distribution from that key. And then they're killing it, and at this stage, that's it, session over. I don't think anybody is realistically going to get to 2 petabytes in normal usage, but if you do something with Mosh and you set it from a server and you just leave it running for a couple of years, then hey, you might, We've talked about rekeying on the mailing list, and rekeying is, enough people are asking for it that it's probably going to happen. When it does, instead of running all the way up to 128 bits, you probably should be rekeyed at something reasonable. SSH1 used to do this. It used to say it would rekey after an hour or it would rekey after a gigabyte. SSH1 died for lots of other reasons. They don't automatically want to go and re-implement what other people have done. That's okay. And you're not going to brute force 128 bits over the network, realistically. It would be noticed, and it would take a long time. SSP is the bit that's allowing roaming. The datagram layer does not, it knows what your source IP address is and your source port is, because we've seen that being reported back to the shell, to the utemp, but it doesn't care. Really doesn't care. As long as the sequence number went up and the thing was encrypted with the same key, we're in business. So we're used to looking at TCP-based sessions, right? Or even on UDP, we sort of tend to trust the IP address that we've started coming from. And if you come in to the anonymous connection to the listener and you authenticate yourself, then you've got a session, and that session stays with that IP address. And we sort of have a layer of protection. It is spoofable, you can break that. It doesn't really give necessarily a lot of theoretical protection, but it gives the firewall vendors something to sell. You know, you just, and of course all the IP tables and PF stuff, the first thing is session state established, just let it through. This guy is UDP listener, you must listen to the whole planet, because hey, we never know whether you moved to Nigeria 3 microseconds ago. That worries me. The protection is that 128-bit key is pretty big, and it doesn't really matter if the Nigerians are trying. Yeah. No, I'm not a cryptographer. I just use stuff. I've asked a couple of crypto people who didn't spend more than about half an hour looking through the code. They say, oh, the implementation looks okay. Certainly from my perspective, the code base for this thing is neat and well structured, so it's very easy to find your way around it. So we think we're happy about it. Roaming itself, of course, we had Vint Cerf up at LCA at 2011 in Brisbane, apologising for the fact that he should have had a different address at the TCP layer from the IP layer, but his room-sized machines didn't really move very much and their interfaces didn't change. And then, of course, he himself was carrying mobile phones and things that don't roam very nicely. So he knows what he's done. He saved himself a few bytes a long time ago. But we're stuck with this decision now. So in order to get roaming, we sort of have to abandon the whole IP address thing, and that's what Mosh is choosing to do. I don't think I even pressed the key then. Oh, that's sorry, I've got the touchpad. I must have got close enough to excite the touchpad, poor thing. Yeah, pretty much said the same thing. The whole thing with TCP and IP and their addresses being tied together is pretty analogous to your landline phone numbers. But mobile phones are sorted out roaming just fine, and what they've done is they've got a different implementation underneath. We don't have the luxury of doing that with IP4. I don't believe that IP6 is really going to help the use case of somebody on a mobile phone switching from one network provided by a third party to another network provided by a third party, so that's fine. It could. But I don't know that we're going to get commercial providers that are interested in giving that to us. I think your own networks. Yeah. So roaming in IPv6 is much more theoretical than practical at this point in time. So they might do it, but in the meantime, this approach does seem to be okay. So the question is, what is okay? Right, I'm not giving this thing a resounding hooray, look, roaming is so fantastic, because this is not my project, I did not write it, I'm just trying to figure out whether I'm going to allow it across my network for my users. Only I work at a university, so it's not my network and my users, it's their network. And they use me. So the normal approach to trying to figure out what's safe for any given environment, because remember we have our 3 different environments, the home, the small business, and the enterprise thing, is you try and have a look at your values and your costs. So if somebody gets in, what was the value of what they can take away from you? The old risk equals likelihood times damage is perhaps a rough word of saying it. Everybody has these trivial things. Nobody's got a really good accepted definition of risk. So what you do as an organisation, you tend to pick one and stick with it, so at least you're consistent in all your analyses. So basically what we say is, okay, what's the damage that could be done if this encryption on Mosh is useless. And the damage that could be done is at any time, anybody in Nigeria could just pick up a session running on your internal servers. The value of that is intensely high because nobody has got much value out of the computer they connect to in their organization. Their value is they're running tmux because they're not running screen anymore. And it's got Windows and it's logged into all of their production servers and it's got a few windows over here as root. That's the value that's being exposed at the front of the organization with this protocol. But what's the likelihood? Now, we've got some well-known ports, so we're going to be attacked. We've got an implementation of software that's trying to do the right thing, and everybody's bit of software will have some fault in the implementation that we're going to find sooner or later, usually later. According to Verizon, their wonderful reports about what things have gone wrong in the world, later means for 79% of businesses, later is over a year later because a third party told you about it, not because you noticed it. And of course, some of these scenarios are always a game over thing, which is what happens if the guy in Nigeria gets control or gets a root shell on your database? Well, depending on what type of organization you are, it's game over. But your likelihood should be nice and low. The other thing that I'm a little bit worried about is compromising the client device that's got the current key in it. So your iPhone, your Android does not have a very good anti-malware environment. If they get something on there that is aware of Mosh and is hunting for Mosh, it will take your session key out and send it to Nigeria. And a few moments later, there'll be packets coming out of Nigeria to your server, and your server will just go, yeah, sure, that's fine. I'll switch to 41 dot whatever. Then you send some packets, and it sort of switches back, and then the two of you start fighting. All they have to do is increase their sequence number, the way that Mosh works. The sequence number is this 63-bit integer at the front of the packet. So they just take it way up to the end, and your application is never going to try a number that high. So they are going to win, and they're going to take your session. They have to have your key to do that. But of course, that's the game over thing, right? If your client device is not trusted, don't worry about what happened. They could just as easily just take over the connection while it's still live on your device in the first place. So the response to risk, a lot of technical people look at a risk inside their sphere and they prevent it from going wrong. They prevent it from happening. And pretty much every single time they do that, their prevention actually pushes the risk out to the next layer up or the next layer down. Ultimately, as Matt was saying this morning, if you push them down, you end up at the hardware. And you can get your hardware and you can slice it and stick it under the microscope and find out what it would have done if you hadn't sliced it. The other way it gets pushed up is it gets pushed up to the human. In some cases, the human it gets pushed up to is the first manager who doesn't understand the problem and says, we accept this risk, carry on with your work, please. That's an enterprise thing. Hopefully, you don't encounter that too much in the real world. But the correct response is that when the benefit of what it is you're doing is greater, much greater than the costs of it going wrong, then go for it. You should do so, because you will get benefit to your business. And everybody's got different risk profile and different sorts of things. Enterprises tend to be very, very risk averse, unless it's about a contract, unless it's about something that the sales force want, or it's a new gadget that the CEO has got, in which case the business suddenly becomes very risk blind. They accept them. But the same thing with the home user, right? You get your cool thing and you enable it. Grand, and just go for it. With no understanding of the consequences. You've just accepted the risk, but you haven't done it consciously. Not to worry. These things are what compromises are made of. So, what's an unsafe thing to allow connection from a known bad location? You know your bad locations in advance because you go off and you get a feed of intelligence from somewhere else. It's the same sort of thing with an RBL list for your email server. Don't accept any email from this guy because we know him to be bad. We can do the same thing with IP addresses coming from 41 dot whatever. Choose the country that you do no business with whatsoever and block the hell out of it. Or allow it only to go to one service like the VPN and audit the hell out of that. And then you can say, if your Salesforce ever go to Nigeria, they can connect with this mechanism, but they can't come with anything else. That might work. An unsafe thing is if you have a user that you know to be compromised, then it would be unsafe for you to allow them to do any work. Unfortunately, you never know they've been compromised because they won't admit to it. You have to look at the behavior, as in, they've suddenly started sending 20,000 messages a second. That's unusual. They're all going to Yahoo and Hotmail and they're advertising drugs that we don't sell. So you have to look at that and you have to respond to that. You don't know in advance when they're going to be compromised. Not to worry. One of the things we do try very hard to do from the technical end is to look at our bits of software that are listening on the network and find out whether we should allow a connection for that. Now, I have just gone and run out of time. I didn't see the 5 minutes, sorry, Kim. So I shall skip a couple of things. Good and bad habits, these are things that people do on a regular basis. There's no given situation in which that is wrong to do. We have a case of servers where we use passwords, not keys, to log in because password implies person at keyboard. If anybody tries to automate their password, they really know they've done something nasty. Whereas if they set up a key and just don't give it a passphrase, we can't tell. And they're not quite so sure they've done a bad thing. Yes, things that will go wrong with proving that you're a human. The similar things I didn't talk about. Of course, you can stick with SSH and put auto SSH on. Fantastic, as long as you're not using two-factor or something like that, because every time it comes back, it wants to talk to you. You can run a VPN. VPNs are very good at reconnecting until you use two-factor, which you should be doing, at which point it's a user interaction to try and get it reconnected, and Mosh doesn't want this, it just wants to keep working. iTerm 2 with tmux control channel. Every time you get a new tmux window, you get a new window on iTerm. So they're not all crammed into one small space. They're scattered out in lots of windows and you can shove them around your desktops and have a great time. Unfortunately, it won't work over Mosh, but it's a good thing anyway. So with all these, re-establishing the session is something which needs the user. The other one is two-factor, the Google Authenticator thing. It sort of fails when everything was happening on the same device. Getting an SMS message to confirm your identity fails if you were coming from the device in the first place that's receiving the SMS message. So I have to go past, is it safe to Mosh? That's the answer. You have to sort out how you are going to decide whether it's safe to use Mosh. I suggest celebrity endorsements. Which means Stefano from Debian uses Mosh, but I bet you he doesn't use it on Debian production servers. So you have to be careful about what you listen to. So I have to go straight to answers, having run out of time. So the answer is yes, yes, possibly, for those 3 use cases. Your home user? Yeah, I think it's absolutely fine. It's got a reasonable level of security for what you need. Small enterprise, small business? Yeah, I think it's probably very, very useful if you're a tech who's roaming around trying to support stuff. For an enterprise, I think there are some great benefits if you require your workforce to be out and mobile and roaming and still be able to get in out of hours and do work for you. So I was going to get Keith from Mosh on IRC, but because I ran out of time, he's going to be annoyed with me. Question?
Do you have an answer to why IPv6 is not supported and why they make you have 1,000 ports open and not just one multiplex?
Why is SSH? Oh, sorry, why is IPv6 not supported? I think it's just because they haven't got around to it in their project lifecycle. Pardon?
They actually supported it.
Oh, last week apparently it was supported. Fantastic. Why do they want you to open lots of ports? It's because when the server starts up at user space, it just has to claim the next port that's available. So if you're limiting the number of users that can run Mosh, you can limit your port range. And you can specify.
All with one port in the protocol that you hold.
No, the process is done with the first user.
It can't multiplex because it's user space. It can't take 2 different users' connections. Kim wants me to finish, so I think to be fair, come and hassle me later so we don't annoy the next speaker. Thank you very much.